Hello, geometry folks. This is Mr. Heeren, and I wanted to we're going to take a little break from kind of four-sided figures and just do a little bit of a review of something you have seen in intermediate algebra, and you might even recognize it. Talking about solving systems of equations. When we solve systems of equations, what we're talking about is multiple variables. And as the name implies, multiple equations. Okay, so these are your steps for solving by substitution. So what you want for when you're solving by substitution is you're just going to follow. You're trying to isolate one variable. Okay, so you're going to try and isolate one variable. And that means, by itself. And then you're just going to use whatever that equals in the other equation. So then you're going to be down to one variable, and then you're going to come back and solve for the other variable. So now if you don't recognize this or you don't really have any clue what I'm talking about, we're talking about solving things such as if I had like 3x plus 2y equals 15, and then x minus 3y equals 7. You're dealing with solving things like that. Okay, so you're looking at the ways that we can do that. So a couple things to notice is that every once in a while you're going to have something that is, when you solve, you're going to have something that is going to be an absolute truth. Like you'll be solving and you might get something that says like 7 equals 7 or 3 equals 3. Well, that's obviously true. So that's going to be infinitely many solutions. Likewise, you could flip it around. Sometimes you might get, 3 equals 7. Well, that's always going to be false. So that's your clue that there's going to be no solution. Okay, so substitution is one of them. So we'll talk a little bit about substitution first. So here's kind of a system of equations that we want to revisit. Okay, so 10x plus 2y equals 10, y equals negative 10. Well, if I'm using substitution, I want a variable by itself, and I have one right here. So y equals negative 10. So what I need to do is then substitute in for y that information. Okay, so you put in what y equals. Okay, so if y equals negative 10, I put in negative 10. Now, I've only got the one variable to worry about. So 10x, I would add 20 to both sides. So 10x will equal 30. X equals 3. In this case, they already told us what y is. So my answer would be 3 negative 10. Okay, so all I'm doing is I'm isolating one variable. In this case, it's already done for me. Y is by itself. So now I'm trying to figure out what x is. So I'd substitute in. So this one gets a little bit trickier. Okay, and what I mean in that respect is that now, y is still by itself, but y doesn't equal a number that's just easily distributed. Okay, so now I've got 15x minus 5, but instead of y, I'm going to replace y with what y equals. So 15x minus 10x minus 15 equals 50. So this becomes 5x, add 15, add 15. 5x equals 65, so x will equal 13. Now, I'm not done. Okay, and this was all algebra. This was all stuff that you've done before, and it should come back to you. So now my last piece is I need to solve for y. Okay, so how do I do that? Well, I know that I've got y equals 2x plus 3. And I know that x is really 13. So y, just from a matter of substituting and simplifying, y is going to be 29. So there's my answer. There's my answer, 13 and 29. So again, I just put what y equals in for y, okay? Then just worked it out mathematically, and then substituted back in and figured out what the other one was. Okay, nothing too terrible. Elimination is a little bit trickier. Elimination is good for when it's really hard to isolate one variable, or I've got numbers in front of every single variable. So, if I've got 3x plus 2y equals 24, and then like 5x minus 3y equals 17, that's going to be a little bit tricky. That's going to be tough to do. It's going to be tough to simplify or use substitution there. Okay, so here what I want to do is put both equations in standard form. That means like x plus y equals some number. You want to work to get one of the variables with opposite coefficients. So that means like a plus and a minus. So like a plus 3 and a minus 3. Okay? So then you're going to add the two equations together. And in doing so, you should get rid of one of the variables. One of the variables should go away. So you solve for the one that's left, and then go back and solve for the other one. So let's take a look at what this entails. Okay, so you see here, and right away when I look at this, I have 4x and 3x, but then I notice I have a 5y and a negative 5y. And remember what I said, I want a plus and a minus of a same number. And that's what I have. That's what I have. So that's what I want to use there. Okay, that's what I want to use. So what I end up doing is I end up adding these two things together. So 4x and 3x is going to be 7x. Plus 5y minus 5y goes away, becomes 0y. 6 and 8 become 14. So 7x will equal 14, and x will equal 2. So now that x equals 2, now I can substitute this in either one, doesn't really matter. So if I go 4x plus 5y equals 6, I know that x is really 2. So 5y equals negative 2, so I get y to be negative 2/5. So there's my answer. So I know what x is 2, substitute that in. Yeah, that's all I do. But the key here is finding a plus and a minus of the same number in front. Okay, so this one presents some issues. Okay, this one has some challenges. It doesn't, the 3x and the 5x, those certainly don't match up. Negative 4 and negative 7 don't match up. But if you notice, the negative 4 and positive 7, they already have opposite signs. So what I'm going to do is multiply everything by the other coefficient, by the other number in front. So that becomes 21x minus 28y equals 70. This one becomes 20x plus 28y plus 12, or equals 12, sorry. So now I have minus 28 and I have plus 28. So let's look at what I have. I have 41x. This kind of zeroes out, that becomes 0. And this becomes 82. So now it's I'm hoping you recognize that it should be a very simple idea. Very simple idea. X should equal 2. So now I'm not done. Okay, I still need to solve for y. So 5x, and I just used the second one. I could have just as easily used the first one. So 5 times instead of x, I want to put 2 plus 7y equals 3. So that becomes 10. Zeroes out, 7y equals negative 7. So y equals negative 1. And there's my answer. So my solution would be 2, negative 1. Okay, so we've done some substitution and we've done some elimination. There are other ways that you can solve. You could graph both lines, but most students don't want to do that. These are just kind of the way that we talk about solving, that they're the most efficient, the best use of your time, basically. So now if we consider this, so it's a parallelogram. So that means 2p plus 3q equals 18, and 5p minus q equals 11. Okay, so now as I look at these, I could do either one. You see you have a negative q there. Technically, there's nothing in front of that q. I could manipulate some things around and do substitution. That would totally work. What I might be encouraged to do, though, is just kind of rewrite or multiply the bottom by 3. So I'll keep the top as is. If I multiply the bottom by 3, I get 17p minus 3q equals 33. And then look what happens when I do that. Plus 3q minus 3q. So that will go away. So I will have 17p. So if I add these things, 17p, that will completely go away. And this will become 51. So a little division later, I get p to be 3. So now to solve for q, I might keep this as is. Go 5 times 3 minus q equals negative 11. So 15 minus q equals negative 11. So negative q will then equal negative 26. Subtract 15 from both sides. So q then would equal 26. So q would equal 26, and p will equal 3. Okay. All right. Now you go to work. Please make sure you do this after 4.1 and 4.2, before the quiz, okay, and before 4.3 and 4.4. Okay, so that's kind of where this fits in, right in here. Okay, I look forward to answering your questions.